We're now going to talk about a special thing that every function has, and that's called the difference quotient. Okay, so we're going to talk, in this video, we're just going to talk about what the difference quotient is. And in the next video, we'll actually talk about how to find the difference quotient. And we'll do several examples. So, the difference quotient is actually the very beginning of what we call differential calculus, what we normally call Calc 1. And the idea behind Calc 1 is if we have a curve, so let's say we have this curve right here, a function, and we're going to call that f of x. We want to know about the slope of that curve. And before, we've always just talked about slopes of straight lines. And what calculus allows us to do is talk about the slope of things that are curved. And to do that, we actually have to use straight lines to help us. So we're going to pick 2 points on our function. So the first one we're going to pick this point right here on our function, and we're going to call that point x, whatever that x value is, and then its y value would be f of x. Then we're going to go down, so this is where x is on the x coordinate. We're going to go down the x-axis some by another variable that we're going to call h. So h is just the distance we've gone down the x-axis. And we're going to find the point on the curve at that point. So if this x-coordinate was x and we've gone down by h, or up by h, I should say, this coordinate would be x plus h. So this point would be x plus h, comma, f of x plus h. Okay, and what we're actually going to do is draw the straight line between those 2 points. And that line is called a secant line. And what we're actually going to do is, since we can't find the slope of a curved line, we're going to find the slope of the secant line. So you should have learned in previous classes that the slope of a line, the formula is m equals y1 minus y2 over x1 minus x2. And it doesn't matter which point is our y1, x1, y1, and which one is our x2, y2. So we're going to let the second point actually be our x1, y1, and the first point be x2, y2. And then when we plug that into our slope formula, this is what we get. Okay, we get y1 minus y2 over x1 minus x2. And we can simplify this a little bit. We're going to have to leave the top exactly as it is. But the denominator, if we get rid of the parentheses, we can see that this is x plus h minus x, and so the x's can cancel out. And that leaves us with the formula for the difference quotient of a function, which is f of x plus h minus f of x over h. And so if we ask for the difference quotient of a function, you'll have to also be given a function, and you'll find this expression. You'll plug in x plus h into the function anywhere there's an x, and then you'll subtract f of x, and you'll divide that by h, and you'll actually simplify the whole expression until you can cancel out the h. And like I said, we'll do lots of examples. And in calculus, what we actually do is we make this h smaller, smaller, and smaller. Because you can see if you picked a smaller h, let's say we actually talk about the slope of a curve at a point. So if we picked this first point, if we made a smaller h, that line would actually be closer to our actual curve. So in calculus, we talk about what are called limits. But if you're never going on to calculus, that's okay. This still gives us really great practice in evaluating functions and doing some algebra with functions.